Hi, my name is Sonia, and my group is Smile, Fred, and Robbie, and we're going to talk about how celestial bodies affect the Earth. All right, the Earth's rotation. So everyone knows that the Earth is on the axis of 23.4 angle. So it's like tilting, in which it creates when it goes counterclockwise, and then that actually affects the 4 seasons, which is summer, autumn, winter, and spring. When it's tilting towards the sun, it'd be the summer, and then south would be winter. And then that whole cycle, when it goes around the sun, it would be 365 days. And then approximately about 4.6 billion years ago, how our Earth started spinning was because of 4.6 billion years ago, a huge cloud of gas and dust started to collapse under its gravity, and then it basically collapsed, and then it started to spin. And then, does anyone know the Great Attractor? No? Okay, so basically the Great Attractor is our gravity anomaly. Sorry. Basically, our intergalactical space in the middle. It is our galaxy is basically going towards it. So, and scientists doesn't know that if it's going to be like a black hole, and they don't know. They think it might be a black hole, but it's actually we're going towards it, so they don't even they don't know themselves. And then next is going to be Smiles.
So does anyone know what is it called when the moon and the Earth go on vacations?
Solar eclipse.
Nope.
Oh.
It's called honeymoon. Get it? So the moon, it shows a different face every night in the sky. Some nights you can see the entire face, which is the full moon. The moon travels 29-day orbit, and its position changes daily. Sometimes it's between the Earth, the sun and the Earth, and sometimes in the back. So sun, Earth, and moon. The moon is it's tied with the Earth, which means that the Earth's gravity drags to the rotation of its axis. And no questions? Okay. Every day, the Earth experiences tide, basically, there's a changes level of the oceans. This is because the moon's gravity, and the moon pulls when the moon pulls the closer the moon is to the Earth, the closer the moon is to the Earth, the lower the tide is, and the farther the moon is from the Earth, it's a higher tide there.
All right, I'm going to talk about how the sun affects the Earth. So the sun is the largest and the only star in our entire solar system. It's called the sun. Its name is actually Sol, S-O-L. It's a G-type main sequence star. So stars are classified with a variety of different names. They got like the white dwarfs, which are come about like after the entire lifespan of a star. After like a supernova, it turns into a white dwarf, and it's basically at like a dormant state where it doesn't give off as much heat as it did beforehand. But our star is a main sequence star, so it's still got quite a bit of life left in it. How stars work is they gradually get hotter over time. So climate is affected by solar radiation from the sun, and there's a thing called albedo, which is kind of like, you guys probably learned about it in like middle school, how light is reflected. You know, you go outside, you wear black clothes in the summertime, you're gonna be hotter than if you wore white. So basically, the Earth, because of the Earth's like snow and because of like the lighter areas on Earth, Earth reflects about a third of all the solar radiation that the sun gives out to it, and it absorbs about 2/3 of it. So that plays a big effect on the climate of Earth. The sun consists of plasma, which is one of these states of matter, and there's solar flares that happen on the sun, which actually give radio interference on Earth. When we're having radio signals, we sometimes will notice that it interferes with them. So, yeah.
Okay. All right. So, the sun, it got too hot. Well, what happened? Let me tell you. Solar luminosity. Get that in your head. Is the total power output of the sun radiated to space if solar luminosity was to rise just 10%. The average global surface temperature would rise from 59 degrees, which is I think like 15 degrees Celsius, to about 116 degrees Fahrenheit, which is 47 degrees Celsius. The atmosphere will be a wet greenhouse and it'll lead to strong evaporation of all the oceans on the planet. The stratosphere will be filled with water, and gradually water will be destroyed by the photodissociation, allowing hydrogen to leave Earth. Did I get that wrong? Or?
Stop reading.
Oh, sorry.
Go ahead.
Oui. Oh, geez, Rick. Go ahead. See if you can do that without looking at your slide.
Okay. Vanished moon. Tides will stop and the currents will stop. The moon helps with all the currents in the water, and it'll stop the gravitational pull will stop them. The Earth's axis will be unstable, which would probably cause like climate change, severe climate change, and shorter days because there's no tidal friction. And the sky at night will have more stars for you to see because there's no moonlight interference. Alright. It would take 1 year for Earth to go day to night, which means it'd be like 6 months of sunlight and then 6 months of just night, dark.
Why?
The water would displace.
That's shocking.
That was close.
Why? Stop. Hit that first bullet. Why would it take 1 year for the Earth to go from day to night?
Because it wouldn't be rotating.
Correct.
It would just be going around, right? And
Around
so,
what?
Around the sun, and then so basically one spot will have its time in the sun, and then since it's not rotating, it's not going to be on the daily, so it's going to have to go around 6 months, and then the other side will, have their time in the sun. But the thing is, though, if the side with the sun, it's going to erode the crust off the top that's getting the sunlight. I mean, you have a shot, maybe, I'd say, like maybe less than 5%, maybe on the dark side for life. I don't know. Probably it'd be possible for me to live it. Let's see, land, and then so basically if the Earth would stop, then the land will basically form around, like along with the equator around the Earth and cause two big ass oceans. One on the top and then one on the bottom of the northern hemisphere and the southern hemisphere. And then, what's it called? Yeah, and then also we would have extreme weather too from not having a rotation.
That concludes our presentation on celestial bodies.
stop moving.
Yeah.
Do you think, what else would happen to like personally us if like the earth would stop?
We're all gonna die.
Yeah,
We die,
just
we-
fly.
Do you think we would like fall or like
No,
slam against the
no,
wall?
it's-
Oh, stop, he's
Alright.
asking.
My bad.
So you're saying if the Earth's rotating and one day it just stops, right? Let me tell you what would happen. Everything, like all the buildings and all that, would be ripped up and then start into the wind, or it'll just go around the Earth like a couple times. Because it just stops full force. You know how fast the Earth is going?
It's like 100
Imagine in your car going 70 miles per hour, you hit the brake, you going out the thing, you know what I'm saying? It's just like that.
So how fast is the Earth rotating?
I can get back to you on how fast it's rotating, but
1,000
I know
miles an
it's
hour.
going super
Thousand
fast.
miles an
I was
hour.
gonna say a little bit.
It's going really fast.
Any other questions?
Yeah, I have a couple for Fred.
Oh, man.
So, why does the sun cause radio, that relationship with radio interference to the sun, where does that cause from?
Well, it's from the solar flares, because like the solar flares release like X-rays that travel like through space, like just radiation that travels through space that interferes with the waves.
Okay, and then, so you were mentioning different kinds of stars, and that the sun is a G-type.
Yeah.
What other types are there?
Well, there's the white dwarfs, there's the main sequence, there's the red giants, there's I believe blue dwarfs as well, and then
Hydrogen?
So is it just the color that determines like the different variations of dwarfs?
it's the
Like,
color and
size.
also how hot and how big it is. Yeah. So like with certain stars, they're too small to actually go through a supernova phase, where they explode and turn into a white dwarf and all that. But it really just depends on the size and color and stuff.
Thank you.
Josh, I just have a general question, if anyone can answer.
Yeah.
It's a genuine question.
Yeah.
Does the Earth's core have anything to do with its rotation?
Yes. So like I think it is because like our Earth is like what's it called, like hydrogen element. It's like
It's a nickel.
I don't know the word
Basically.
for it, but basically, if the Earth wants to stop rotating, the core is still going to be moving inside the Earth. Even if the Earth stopped rotating, the core is always going to be moving.
Is that true?
Yeah.
I have a personal question. How long do you think we got on this earth?
300.
About 63 years.
I would say
For you.
yes. The way like climate change and stuff like that, and like everything's going on fire and basically I don't think we have a long time.
So we can't really stop global warming if we, like, it's eventually
Well,
gonna.
I mean, technically, this, like I was saying, the sun continues to get hotter, but I mean,
Right.
it's not going to actually affect us with the sun getting hotter for like millions of years, 4 billion.
4 million
So,
billion.
but the thing is, because of how bad we treat the Earth, I mean, humanity's probably going to die before that unless there's an extremely big breakthrough.
Unless we get be like the dinosaurs and get wiped out with a big rock.
Finally.
Big rock.
All right. I'm going to shut you up there because now I'm bored.